Okay, moving on to part B. Let's keep going with my favorite topic. My only concern here is to reiterate one more time that just because I'm doing it one way does not mean it's the only way to do it. So all of these problems have multiple avenues to be proven, and if you have any questions on whether yours is correct, please just see me. With that, let's get started here. So here's my left side and here's my right. So I'm definitely going to start on my left side because the right side doesn't have too much going on. So I'm going to start by writing everything in terms of sine and cosine. And we end up getting fractions over fractions. So my next step is going to be to correct that the tangent is not cosine over sine, it's sine over cosine. Forgive me. Okay, so that's our first step, is to fix that. The tangent is sine over cosine. I hope that makes sense. Extra points to you if you noticed that while I was writing it. High five. All right, so now let's common denominator. So the cool thing is it looks like in my numerator, I already have a common denominator of cosine. And then in my numerator, it's just 1 plus sine. In the denominator, my common denominator will be sine. So it looks like I will have cosine plus cosine times sine all over sine. So when we have a fraction over a fraction, here's the reason, don't know why. Flip the second number and multiply. That's the song some of you have taught me. But yes, we flip and multiply. So our first fraction stays the same, and then I'm going to flip my second fraction. Okay, and obviously I would like to cancel some things out, but hopefully we are getting to know that we need multiplication, only multiplication, in order to cancel things out. So let's try to factor this denominator right here, and I notice that they each have a cosine term. So let's factor that cosine out of the denominator. And now I have all multiplication. And hopefully you see right away there that my 1 plus signs cancel out. And talk to me if you're still not getting how to factor this. But if they have a common factor, you pull it out front, and then 1 is the placeholder since I pulled that cosine out front. And then in the second term, all that's left would be the sine. Anyway, so I cancel out the 1 plus signs, and then I'm left with 1 over cosine, that's just secant, and sine over cosine, that's just tangent, right? So that's what I wanted. I mean it's flipped, but multiplication order doesn't matter, so we can easily write this as tangent times secant, and now it looks exactly the same as our right side. I would not take off points if you kept it like this, because it's pretty obvious that multiplication, the order does not matter. Whew, that was a doozy. Basically, common denominators and factoring. So part C is going to be challenging if you do not have your identity sheet out. But if you do have your identity sheet out, then you're going to notice that my numerator is a sum and difference identity. So it's cosine, so I'm looking at my identity sheet, and I'm looking at cosine alpha plus beta, and in this example it's x plus y, but very similar, right? And I'm just using my identity in my numerator. Awesome, so there's my numerator. My denominator is this, and it's very tempting to want to cancel this and this, right? But we cannot do that. Let's see if I can undo that because that's incorrect. We can't do that because of this subtraction. We cannot cancel things out unless we just have multiplication. So that's kind of frustrating, but let's try to think, can I factor anything out? Nope, in my numerator, I have no common terms. So what we want to do in this case is split up our common denominator. So oftentimes we try to get a common denominator. Now we're going to break it apart. So that means just putting this over the denominator and my second term over the denominator. So it's working backwards, but I hope it makes sense why this is true. Right? It's just like saying x plus 5 over y is the same thing as x over y plus 5 over y, right? It's just working backwards when usually we're working this way. So, yeah. Talk to me if that's not making sense. But now let's see what happens. This completely cancels out to 1. And sine over cosine, that's just tan y. And sine over cosine, oh my gosh, is tan, what? Cosine x. Oh my gosh. Sorry, guys. See, even I make mistakes, so it's okay if you make a mistake too. That's a cosine x. So sine x over cosine x is tangent x. Sine y over cosine y is tan y. Sorry about that. Awesome, and that's exactly what I wanted. I can't believe I made 2 mistakes. It is Thursday evening at like 5:30 p.m. I think it might be time to go home. But I'll keep rolling here. We got this. All right, so part D here. Hopefully these identities look familiar. Sine of 2x. I can use a double angle identity to rewrite this as 2 sine times cosine. Oops, I didn't really talk through my process here, but I hope it makes sense that obviously there's not a ton going on the right side. So I'm going to start with the left side here. And I get 2 sine cosine in the numerator. And then in the denominator, stop what you're doing and pay attention. I'm substituting in for cosine of 2x. When I substitute in, I want to use parentheses because I have to subtract this whole expression. That means I have to distribute this negative. I mean, if it helps you, you can draw in a -1. We have to distribute a -1 through. So I get 1 minus cosine squared plus sine squared. So that's the #1 mistake I've been seeing people make, is they leave this as a minus. But because I'm subtracting the whole thing, I get a minus minus, which makes a plus. All right, so my little thought bubble here is that cotangent is cosine over sine, right? Okay, so do I want any cosines in my denominator? No, I want to hopefully kick that out of there. So let's rewrite 1 minus cosine squared as sine squared. And sine squared plus sine squared is just 2 sine squared. And then what do I notice happens? The 2's cancel, and one of my sines cancel, and I'm left with just cotangent. Awesome! So 1 minus cosine squared, I substituted that in for sine squared. Okay, part E. This one in particular, I can think of like 3 different ways to do it right off the bat. I think the one that most people are going to enjoy is to think about this as two fractions and finding a common denominator. So let's multiply top and bottom here by 1 plus cosine, 1 plus cosine, and I'm going to get 1 plus cosine minus sine squared all over 1 plus cosine. And remember, we can't cancel out those 1 plus cosines because I have subtraction, right, and addition. I don't have multiplication. But I'd like to cancel out the sine squared because my answer is cosine. So let's rewrite this as 1 plus cosine, oops, I'm running out of room, minus parenthesis 1 minus cosine squared. Notice my parentheses because, again, that negative is going to distribute. So I will get 1 plus cosine minus 1 plus cosine squared. I'm sorry that I crunched that in here. Let me show it a little bit bigger up here. I hope it makes sense again. Minus, 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 minus is a plus. Minus 1 is a minus 1. Awesome. Be very careful about that. And talk to me or talk to someone if you're still confused. Okay, this is all over 1 plus cosine. I'm getting excited because 1 minus 1 is 0. So I don't really care about adding 0. And so I'm left with cosine plus cosine squared. Well, I can factor out a cosine, right? So this is up top is just cosine plus cosine squared. So I can definitely factor out a cosine, and I'm left with 1 plus cosine over 1 plus cosine. And suddenly, I see the light, and I'm done. So big thing is being able to factor things out, right? They both have one term of cosine, so I bring it out front. I took out this cosine, so 1 is the placeholder, and there's 1 cosine left, because that was a cosine squared. So that's how that works. And then that becomes my numerator, they cancel, and I'm left with just cosine, which is my correct answer. All right, let's see if I have time to do this one. I think I do. So these recordings only let me do 15 minutes at a time, but I got this. Okay, so left or right will work in this case. So I saw one student, I was really impressed. They started on the left side and they just divided every term by sign, right? So, because think, we want this to become a 1, right? So we can just divide everything by sign, right? I didn't think to do this right away, but I saw. She knows who she is. Hour 7. That's all I'll say. If we just divide everything by sign on the left-hand side, we get sine over sine, which is 1, sine over sine, which is 1, and cosine over sine, which is cotangent. That's exactly what I wanted. So this is method 1. I'll quickly go over method 2, just in case that one didn't tickle your fancy. I could go the opposite way. So I could start with my right-hand side, and I can do 1 over 1 minus cosine sine. And I would just have to find a common denominator. So it's going to be 1 over, my common denominator is sine. So I would get 1 over sine minus cosine over sine, right? Okay, well 1 over, that's just telling me to flip it, right? Flip and multiply, and I would just get sine over sine cosine. Does that make sense? If you just flip and multiply this by 1, this is what we get, and that's our left side. So either method will work. Obviously, you don't need both, but pick one.